Okay, so on this first one, we're asked to graph, and we're gonna graph the sine curve just as we did on the last homework. But now I give this extra requirement, which is saying, here's where I want your graph to start. Not so your other graph started at 0. This one I want you to start at -3 pi over 10. And it may not be when the graph may be like only, who knows what quadrant you're in at that time. We got to figure that out. And then I want you to end at pi over 2. So it may be like a quarter of a period, it may be the full thing, you may do like 3 periods, who knows? So we got to figure that out, and I'm going to show you how to do that. But so this is this extra requirement that's on us, and so I'll lead you through one, and then I'll have you try number 2 on your own. So when you do this, when you have this extra requirement, because we don't know how the curve's going to start, or even like where to put the y-axis in reference to this, we're going to save the graph for the very end. We're going to work on the x-axis a lot, and that's the thing we need the most practice with. So not as hard as you may think it is at first. So we're going to give ourselves a lot of room for that x-axis, and we know what to start at because it tells us. What are we going to start at? -3 pi over 10. Okay. Now, I don't know how many marks to put because I don't know how far we're going. And so my next thing I need to figure out is how big should my interval be for each mark, right? And that's something you had to do for your homework too. How did you figure that out? What did you do? You take your angle, 5x, and set it equal to what? Pi over 2. Because pi over 2 is the distance from 0 to, it's like your first quadrant, and that just gives you your first marker of how far we should pace ourselves out. And so we're going to multiply by 2 and get 10x equals pi, and then divide by 10, get x is pi over 10. And so this is how much we're going to mark out each thing. So we're starting at -3 pi over 10, and so my next one's going to, if I add pi over 10, I'm going to be at -2 pi over 10. And then the next one would be, oops, not -3, negative pi over 10. And then 0, and that's where 0 is on the x-axis. That's where your y-intercept is. So we found our y-intercept. And then we got pi over 10. And then 2 pi over 10. And then, when do I stop? We stop at 5 pi over 10, because pi over 2 is the same thing as 5 pi over 10, right? And so that's when we're going to stop. So it's 4 pi over 10 and 5 pi over 10. Okay. And so then after that, I'm going to put on my max as that going to be at 3, right? And my min's going to be at -3. And my work is in my way now, so I need to move that. So if your work is in your way, all you got to do is lasso it like this. Okay? And then you grab that and just move it over to the side. Okay? That's all you got to do. And so there's our max, our min, and so your first period is going to go from 0, and it's going to go through the first 4 quadrants. And this is the positive sign, so it starts at 0, goes up to its max here, comes back down, right? So that's one period of the function, but we need to keep going just one more quarter, right? So we're going to end like this. So we hit quadrant 1, 2, 3, 4, and then quadrant 1, and then stopped. But we need to go backwards now. And notice you always want to start at your y-axis because that's how we've memorized what the shape looks like from the y-axis. I didn't want to start at negative 3 pi over 10 because I don't know how to start that. Okay, so I need to go backwards now. And when you're going backwards, well, then you're going to go quadrant 4 here. So it's going to drop down. And then come back up. And then end right here. Right? And there we did it. We have all the values we need on the x-axis. We labeled our y-axis. And we have the correct shape. And this is a sine curve. And you may think, well, you know what, this looks like a cosine curve because it starts at a high, right? But where it starts, you always got to look at the y-axis. It's starting at 0 at the y-axis. That's why it's a sine curve. Okay. All right. Any questions on that before I let you try one on your own? Okay. So number 2, graph y equals negative 5 times the cosine of 3 pi x over 4 from negative 10 over 3 to 2. What are you guys getting for the interval? Like, how much are you going each time? 2/3. Okay, good. So I'm not going to show you the whole thing. I just want to make sure you're starting right. Here's my work over here to get 2/3. Here's where you're starting. Keep going. You have to do what? All right. So I didn't finish yet. I'm going to finish right now, but you start at negative 10 over 3. You're counting by 2 over 3, all the way until you get to 2, which is 6 over 3. And so when I start my graph, and here's why I didn't want to finish, because I want to show you how I'm starting. I'm not starting over here. I'm starting at the y-axis. And it's a negative cosine, so at the y-axis, I have to start at the minimum. And I move up, and I'm not able to complete the full period of that function. What is the full period of that function equal to? The period of this function, let's write that down. What would it be? 8 over 3. Because the period of the function is how far does it go to do 4 quadrants? I have 3 quadrants at 6 over 3. So when I get to my 4th quadrant, it'd be 8 over 3. And that's the full period of that function, right? What do you call the distance between the middle and the height, or the max? The amplitude. And what is that? 5, right? Okay, so I'm just going to go back and finish this here. So it looks like that. That's the full curve right there. And you don't have to put these quadrants here, but I'm just putting it here so you remember. This is connected to the unit circle, and every 4 quadrants, that's a full circle, and that's why it's repeating, right? And so wherever you see quadrant 4, you see the same exact piece, right? Where you see quadrant 1, you see the same exact piece. Go on. Okay. All right, so now we're going to work on, what if I give you the picture, you got to write the equation. How do we do that? Okay, so number 3, here's your picture. Okay, so we have a curve. We see that we got a number on the y-axis, -4. We got a number on the x-axis, 10. And that's all we have. And there's 3 things you need to graph, and those are the same 3 things you need to write an equation. One of them is to recognize what shape am I looking at. Is this the positive sign, the negative sign, the positive cosine, or the negative cosine? There's just 4 shapes that we put in our notes, and I said, hey, this is like learning your letters in kindergarten again. You have to memorize what it looks like and know how to draw it. Which one is this? Positive sign. Okay, so that's the first thing you need. Second thing you need is, well, what's the amplitude? And that's how I start. So I'm gonna once you have that, you can almost finish your equation. So this is gonna be y equals 4 times the sine, and the only thing I'm missing is the angle. And that's the hardest part, and that's the hardest part of graphing too. But we can do it. It's not that hard. But at first, I'm going to say, well, I don't know what this number is. I'm going to put a b there because in general, it looks like this: y equals a sine of bx. I knew what a was. I got my amplitude 4, right? I'm not sure what b is, so it's b times x. Okay. And what number do you think is going to help us find this one? You look at it, you find a number on the x-axis, and it doesn't matter where you are at. Like, but you have to know where you're at. Okay, so I'm going to use the 10, but where's the 10 at in terms of quadrants? 4th, right? Because I'm going to put them in here so you see, right? Use 4. You split this into 4 parts, right? Because this is the full sine pattern. Here's quadrant 1, 2, 3, 4. And typically, we just work with quadrant 1. And when we work with quadrant 1 stage, we put pi over 2. But because I'm working at quadrant 4, I'm not going to use pi over 2. What am I going to use? 2 pi. Because let's go back. This is 0, pi over 2. Quadrant 2 ends at pi. This quadrant 3 ends at pi over 3 pi over 2. and then this is 2 pi, right? So quadrant 4, which is right here, goes between 3 pi over 2 and 2 pi, ends at 2 pi. So I know I want 4 sine of 2 pi, right? Because that's where we're at. And so I'm going to take bx and set it equal to 2 pi. And that's going to help me solve for b. So bx equals 2 pi. And sorry, what's x at that point? I'm going to plug in 10, right, for x. So b times 10 equals 2 pi. And divide by 10, you get b is 2 pi over 10. Always reduce your fractions and for these kinds of things. So we got pi over 5. And so now I can write my final equation. Y equals 4 times the sine of pi over 5x. And that is the equation of that curve. Okay? We're going to do this 2 more times. So if you didn't get it this time, we're going to give you some more opportunities to catch on. But any questions in this process? Yes? This is just a general form. It came from our notes last time we were together. So it's just a general form of the sine curve that we're working with, where A deals with the height of the curve and B deals with kind of how far it goes this way along the x-axis. Okay. So next one, here's a picture, and I need to give you one more piece of information. This is a pi over 7, okay, on the x-axis. Take, I don't know, 30 seconds before me just to get started. Maybe a minute. See what you can do with it. So, what shape is this? Negative sine. Good. And the amplitude? 2/3. So you better start like this. Y equals negative 2/3 sine. And then we're got to fill in the blank here, right? And at first, just put a b times x, and we need to find out what b is. And the pi over 7 is going to help us. But you better know where that is in terms of which quadrant, right? But before we answer that, what's one period of this function equal to? What's one period of this function equal to? 2 pi over 7. Good. Here's how we know. Okay. Break it up into your 4 quadrants. So break this full curve. I gave you extra, right? This is where that first pattern ends, right here. Okay? And so if this is pi over 7, if you double that, you get 2 pi over 7. That's why it would be 1 period for that full length of the pattern, right? So pi over 7 is landing at the end of which quadrant? 2. Okay. And so quadrant 2 starts at pi over 2 and ends at pi, right? So we want this to be y equals negative 2/3 sine of pi. So we want bx and pi to be the same thing. When x is what? pi over 7. So what we're going to do is say, well, b times pi over 7, that's our x value, should equal pi at that location. And then we're going to solve for b. I'll multiply both sides by 7 to get b times pi is equal to 7 pi. And then I'll divide by pi and get b is equal to 7. And now I found it, and now I can finish it off by writing my full equation. Y equals negative 2/3 times the sine of 7x. That's how writing equations go. Question on that one? I got one more example for you, but if you have a question on that one. Got lost? Okay. You okay with the first line here? Negative 2/3 sine. So you know it's a negative sine curve, you know the 2/3. It's this part right here, right? Bx. Were you okay realizing that, okay, this is halfway through, this is at quadrant 2? So you need to, once you know the shape, you got to know where the shape starts, how it starts and ends. So you got to know that that right there is 1. That's what the shape of the negative sine curve looks like. Once you know that, then you split it into 4 pieces, and you got your 4 quadrants. And so I say, oh, I'm halfway through that shape. And that's why halfway, a full circle would be 2 pi, halfway would be at pi. That's why I'm putting this right here. I know I need to evaluate it at pi, and so I'm setting bx equal to pi in my equation. That's good. If I gave you pi over 7 here, guys, then where would I be setting bx equal to? 3 pi over 2. That would be right here, at the end of quadrant 3. Okay. So let's try one last one. This is now no picture, just words, but you can picture it in your head. Okay. Give the equation of the positive cosine curve with the amplitude equal to 5 and the period equal to 1/2. And you can always draw a picture if you want to. Whatever helps you come up with the equation. Okay. I didn't finish it, but I started. I added a picture. You didn't need to do this, but picture. And we got the 5 is the amplitude. It's a positive cosine function. The total is set. Period is 1/2. That means at the end of our shape, that's the distance to complete our shape, right? That's where the 1/2 would go. And so that's at the end of quadrant 4. And so we know we want this to be 5 cosine of 2 pi. So we want the bx to equal 2 pi. And so bx equals 2 pi, and that happens when x is what number? 1/2. So a half of b is equal to 2 pi. So I multiply both sides by 2, and I get b is equal to 4 pi. And so our final answer is y equals 5 times the cosine of 4 pi x. All right. So homework is page 5 and 6, and you guys got, I don't know, 10 minutes to start on that, okay? Page 5 and 6.